Creational patterns, how objects are created. These patterns abstract the instantiation process and give flexibility in object creation. Singleton. What it does: ensures only one instance of a class exists and provides a global access point. How to implement in JS: use a module, closure, or a static property inside a class. The idea is to check if the instance already exists before creating a new one. Factory. What it does: creates objects without exposing the instantiation logic to the client. How to implement in JS: use a function or class method that takes a parameter, like a type or config, and returns different types of objects based on that input. What it does: builds complex objects step by step. How to implement in JS: create a separate builder class with chainable methods that configure different parts of the object, and a build method that returns the final object, prototype. What it does: clones existing objects to create new ones. How to implement in JS: leverage JavaScript's built-in prototypal inheritance, object.create, or define reusable methods on the prototype chain. Abstract factory. What it does: produces families of related objects without specifying their concrete classes. How to implement in JS: use multiple factory functions grouped under one superfactory that returns related components, like UI widgets for different OS themes. Structural patterns, how objects are composed. These patterns define ways to compose objects to form larger structures. Director. What it does: converts the interface of one class into another expected by the client. How to implement in JS: wrap an existing object or API in a new interface that exposes the methods your app expects. Decorator. What it does: dynamically adds behavior to objects. How to implement in JS: wrap functions or objects inside another function/object that extends their behavior, for example, logging, authentication. Works well with higher-order functions Passad. What it does: provides a simplified interface to a complex subsystem. How to implement in JS: create a class or module that exposes a clean API and internally manages multiple components or services. Proxy. What it does: acts as a placeholder or controller for accessing another object. How to implement in JS: use JavaScript's proxy object, a native feature, to intercept and control access to another object, adding things like caching or validation. Composite. What it does: treats individual objects and compositions uniformly. How to implement in JS: use a class or structure where both leaf nodes and containers implement the same interface, for example, DOM tree nodes, nested menus. Behavioral patterns, how objects communicate. These patterns govern the interaction between objects but observer. What it does: allows objects to be notified of state changes in other objects. How to implement in JS: use event emitters or callback registries. Objects subscribe to a subject, which broadcasts updates to all observers. Strategy. What it does: defines a family of interchangeable algorithms. How to implement in JS: pass different functions or strategy objects to a class or method. Useful for filtering, sorting, or changing behavior at runtime. Command. What it does: encapsulates a request as an object. How to implement in JS: define command objects with execute methods. This allows for queuing, undo/redo, or logging dies state. What it does: allows an object to change its behavior when its internal state changes. How to implement in JS: store the current state as an object, and change behavior by switching state handlers, objects with consistent method names. Mediator. What it does: centralizes communication between objects to avoid tight coupling. How to implement in JS: create a mediator module or class that handles interactions between components, rather than having them reference each other directly. Chain of responsibility. What it does: passes a request along a chain of handlers. How to implement in JS: create a sequence of handler objects/functions. Each decides whether to handle the request or pass it along. Atom symbol emoji. React, UI library with functional roots. React encourages component-based architecture, which naturally aligns with several patterns. Component pattern, composite. React's entire model is based on the composite pattern. Components can contain other components, treating individual elements and groups uniformly. Higher order components, decorator hawks, are functions that take a component and return an enhanced one, effectively decorating it with additional behavior, like authentication, analytics, etc. Hooks, strategy. Observer React's hooks can implement strategies, for example, use different logic for fetching data, and use effect can observe state changes and trigger side effects, mimicking the observer pattern. Context API, mediator. Singleton context acts as a shared, centralized store for app-wide state. It serves as a mediator between components and a singleton for global access. Render props, strategy, template method. Similar to strategy, It passes a render function, or logic, into a reusable component, allowing flexible rendering strategies. Angular, full-featured, opinionated framework. Angular's structured nature and dependency injection system makes several design patterns fundamental. Dependency injection, DI pattern core to Angular. Services and components are injected rather than created directly, decoupling dependencies. Observer pattern, RxJS. Angular's reactivity relies on RxJS observables, a classic example of the observer pattern. Module pattern. Angular uses modules to group related components and services, aligning with the module pattern for encapsulation and separation of concerns. Facade pattern. Angular services often act as facades, hiding complex logic, like HTTP calls or state, behind a simple API for components. Command pattern, forms, validation form controls and actions encapsulate operations, enabling undo, validation pipelines, etc. Node.js, runtime environment for JavaScript. Node.js is event-driven, making several back-end patterns essential. Module pattern. The require and import/export system follows the module pattern, isolating logic and avoiding global scope pollution. Observer pattern, event emitter. The node event emitter class enables event handling. Objects can register callbacks for certain events. Singleton pattern. Modules are cached after first import, so any object exported is effectively a singleton, shared across the app. Factory pattern. Common in creating reusable components like database connections or HTTP clients depending on configs. Proxy pattern. Useful in middleware, where objects/functions intercept requests or actions before they reach the target handler. Express.js, minimalist web framework for Node.js. Express is unopinionated, yet still makes use of core patterns. Middleware, chain of responsibility. Each middleware function processes a request and passes it on, perfectly demonstrating the chain of responsibility pattern. Router, facade. Express routers encapsulate logic for a root group, hiding complexity behind a clean interface. Factory pattern. Used when dynamically building root handlers or middleware based on configuration. Command pattern. Each request handler acts as a command that gets executed based on the incoming request context. Nest.js, framework built on Node.js with Angular-like architecture. Nest.js is highly structured and heavily pattern-based. Dependency injection. Like Angular, Nest.js relies on DI to manage and inject services into controllers or other providers. Decorator pattern. Decorators like add-controller, add-injectable, and add-get-add metadata and behavior, classic decorator pattern use. Module pattern. Modules organize services, controllers, and providers, isolating functionality. Facade pattern. Services hide the implementation details of business logic, databases, or external APIs from controllers. Command pattern. Nest.js CLI commands, as well as service-level operations, can be modeled as command objects. Next.js, React framework for full-stack apps. Next.js builds on React with powerful routing and server-side capabilities. Factory pattern, get server-side props, get static props. These functions dynamically build and return props based on request or environment, similar to factories. Strategy pattern, data fetching. Developers choose between static generation, server-side rendering, or client-side fetching, different strategies for delivering data. Decorator pattern, middleware. Plugins. Middleware enhances request handling dynamically, following the decorator concept. Template method pattern. Pages follow a structure with predefined lifecycle methods, like get static props, get layout, where custom behavior is inserted. Proxy pattern. API routes often proxy calls to external services or microservices, controlling and formatting input/output.